Hello, welcome back to the channel. So let's move on to a new concept which is based on the test for convergence or divergence. So in this video, we'll cover the comparison test that we use in order to evaluate whether a definite integral converges or diverges. So there are actually multiple tests that you can use in order to evaluate or in order to check whether a definite integral converges or diverges. So comparison test is one of them, and it is also a very famous test to evaluate whether your definite integrals diverges or converges by using this simple comparison test that we'll cover in this video. So in this video, we'll cover all the concepts that we use in order to check whether a definite integral converges or diverges based on the comparison test. And in the next video, we'll actually use this comparison test to evaluate this very famous definite integral over here. We'll just check with this comparison test whether this definite integral converges or diverges. So before we move on to the comparison test, let's define some variables over here. So let a be a real number and f and g be the functions that are defined and continuous for all values for x greater than equal to a. So you are assuming two functions and a real number a for which these functions are continuous for all the values of x greater than equal to a, right? So both of your functions are basically continuous for all the values greater than equal to a, right? So after we defined all the variables, there is one very important condition that you have to first check before using the comparison test. So you know that in comparison test, basically what it means by comparison is we'll have two functions and we'll compare one function with another function and then see whether the function for which we are calculating the definite integral for converges or diverges based on the second function, right? So that is why in comparison test, for your second function, for your function which you are comparing your definite integral with, that function should satisfy this criteria over here. So for example, if you are checking whether this definite integral, the definite integral from a to infinity of f of x dx converges or diverges by comparing it with another function, for the guess of the another function, your function should definitely satisfy this criteria over here, that your function should always be greater than equal to 0 for all the values of x for which you are calculating the definite integral for. So that is the very first important criteria that you have to consider while choosing the second function for which you will compare your first function with. And then once you are done with the guess of this function, the correct guess of this function, the second function which satisfies your criteria, then you'll evaluate these two conditions and check whether your integral converges or your integral diverges. So the comparison test is very easy if you see it through a picture. The first case is if your absolute value of f of x, the f of x for which you are calculating the definite integral for which you are checking whether the integral converges or diverges, if the absolute value of f of x, which is denoted by this, if the absolute value of f of x is always less than equal to g of x, your g of x, which is always greater than equal to 0 for all values of x greater than equal to 0. So if that's the case, if your absolute value of f of x is always less than equal to g of x for all the values of x for which you are calculating the definite integral for, then if this is the case, if your g of x converges, if this integral converges, then you can clearly state that your definite integral for f of x dx with the same bounds will also converge. And this is what you can also reasonably argue by looking at the picture, right? So if we know that this area under the curve converges, that means we have a real value to this area under the curve, and then we have to check whether this area under the curve diverges or converges, then we can clearly state that because of comparison test, this area under the curve converges, so that is why this area under the curve will always converge. So that is the first criteria that we can use in order to check whether the definite integral converges. And now based on the second criteria, if your function for which you are calculating the definite integral for is always greater than equal to g of x, so if it resembles this visual appearance over here, if your f of x is always greater than equal to g of x for all your values of x for which you're calculating the definite integral for. So if that's the case and you know for sure that your g of x diverges, then clearly your f of x will also diverge. And that is what you can also reasonably argue by looking at the picture. If we know that this area under the curve does not have a real solution, then we can definitely state that this area under the curve will also not have a real solution, right? Because it adds on to the previous area which did not have a real solution, right? So that is why these are the two cases that you can use in order to check whether your definite integral converges or diverges based on these two cases over here, right? So there is also one more important point that you have to consider in order to use comparison test. Whenever you are using comparison test, just don't confuse these cases with their complete opposites. So for the case A, while this condition is true, it is not necessarily true if your g of x and the absolute value of f of x are swapped with each other. So if this is the absolute value of f of x and this is g of x, and your g of x converges, you cannot definitely state that your f of x will also converge because of your g of x being convergent. So don't confuse these two cases with their opposites. And that was an important point that I wanted to share before wrapping this video. So that's it for this video. Again, feel free to comment down in this video if you have any doubts. Don't worry if that seems complicated. We'll go over this example in detail in the next video and use this comparison test that we covered in this video. So stay tuned for that. Follow the channel in order to get notified about the other videos that I'll be uploading. Stay tuned. Thank you so much for watching. Bye bye. Take care.